Hey, this is Michael Withers, and I'll be covering Chapter 11, Section 4. Um, go over data mining and some techniques used to mine data. Data mining is the process of analyzing large databases to identify useful patterns. It's similar to machine learning and artificial intelligence, and it's also similar to statistical analysis. Data mining is part of the process of knowledge discovery in databases. Types of knowledge discovered can be represented by rules. For example, the statement young women with annual incomes greater than 50,000 are the most likely to buy small sports cars. These rules are not universally true but have degrees of support. Knowledge discovered through the application of machine learning techniques is represented by a model. Okay, there are different types of tasks associated with data mining. Those are predictions, associations, and clusters. So predictions are identifying the most likely outcome or behavior based on known attributes, such as if a person applies for a credit card, the company would like to predict if they're a good credit risk based on attributes such as their age, income, current debts, and debt repayment history. The rules for the predictions are derived from the same attributes of past and current cardholders. Associations are making connections between events, such as books that tend to be bought together. If one of those books is purchased online, the system may suggest the other associated books. So you see on Amazon, you go to buy an item, and it'll say, see other items that other people have bought. Kind of group them like that. Clusters are identifying occurrences of similar events. An example of a real life scenario, there was a cluster of typhoid cases that occurred around a well. At some point, someone looked into it, and the water in the well was discovered to be contaminated. So classification is an important aspect of data mining. One goal of data mining is to determine the class of an item. Once the data is analyzed, each item should be classified. Classifying is easy for the human mind, but automating the process is kind of tricky. In order for a system to classify items, it must identify correlations between attributes within each class. So this can be done using training instances, and training instances are just a set of items from various classes along the class they belong to. So the items will be labeled by humans with the class that they belong to in order to train the system. There are 4 classification techniques that the book mentions. Those are decision tree, Bayesian, support vector machine, and neural network classifiers. So decision tree classifiers, they're widely used. Each leaf node is a class. Each internal node has a predicate, condition, or function. Then each predicate is evaluated as data is passed through to ultimately find which child to go to, thereby identifying its class. Bayesian classifiers use Bayes' theorem to find the distribution of attribute values for each class in the training data. And when analyzing new data, the distribution information is used to estimate the probability of that data belonging to each class. Support vector machine classifiers, they're found to be very accurate and versatile across a wide variety of applications. Training points are graphed, then lines are drawn to separate one class from another. As you can see in the graph, second one on the left side, all the X's are on one side, O's are on another, and there are different lines going in different directions. And they all 5 of those lines separate the classes. But the darker line, the bolded line, is the maximum margin line. And this is the line with the maximum distance from the 2 closest points from within each class. Once in place, any new points will automatically be part of one class or the other. The last classifier the book mentions is neural network. Training data is used to train artificial neural nets. They're made of several layers of neurons, and each layer is connected to the preceding layer. Functions are applied at each neuron, and those compute weighted combinations of activations of input neurons, and they generate outputs based on the weighted combination. The neuron with the maximum activation for the input decides the predicted class. Then there are deep neural networks, and those are neural nets with a large number of layers, and these tend to be very successful. The last thing that the book mentions about data mining is text mining. So it applies data mining techniques to text documents. So type of tasks that text mining might do is sentiment analysis, which basically determines the positivity, negativity, or neutrality of elements throughout a document. And then there's also information extraction, which is pretty useful in a lot of areas. Information extraction creates structured information from textual descriptions. Entity recognition is a key subtask for identifying mentions of entities in text and disambiguating them. And that is the process of figuring out what exactly the entity is being referred to in the case of multiple entities with the same textual identity. So two people are named, as the book mentions an example, Michael Jordan. One's a basketball player, another is someone that was important in the computer science world. And the key is trying to figure out who the document is referring to. And then the extracted information can be represented in knowledge graphs, and the book doesn't really get into how so. So just to summarize the chapter, data analytics refers to the processing of data to infer patterns, correlations, or models for predictions. Data warehouses help gather and archive important operational data for decision support and analysis on historical data. Data lakes are repositories where data can be stored in multiple formats. OLAP tools work on multidimensional data to help analysts view data summarized in different ways. Pivoting, slicing, dicing, roll-up, and drill-down are some features of OLAP systems to promote data visualization. Data mining is the process of analyzing large databases to identify useful patterns. Tasks include predictions, associations, and clusters. Classification techniques are used in data mining and include decision trees, Bayesian support vector machine, and neutral network classifiers. Thank you very much.